Hello everybody, it has been some time since I did a video. I've been very busy the last couple of weeks, but I am working on some new videos. They'll be coming out soon. But I figured I want to do something different today and just do an unscripted, off-the-cuff video. So this one will probably be terrible because, yeah, I don't do very well with unscripted videos. But it's kind of like Space Engine, but instead of looking through space, I'm actually going to look through the EXXON 1982 climate memo that I keep ragging on about, because it's a really fun and kind of annoying read. So, yeah, this video will probably be terribly boring. Luckily, no one will watch it, so this is mostly just to fill in space, because I like to do at least one video every couple of weeks. I don't like having huge gaps between content, so bear with me. But yes, this is a memo from 1982 that was written by EXXON, and as you can see highlighted here, it was restricted to EXXON personnel and not for distribution externally, which is ironic because it was leaked a few years ago and now everyone knows about it. I'm actually currently in the process of printing this off and sending it to all of EXXON's corporate offices just to annoy them. But anyways, there's a reason for that. So we're gonna carry on. I've read this multiple times through, so I have a lot of it, a large sections memorized, so I can read it faster. Otherwise, reading aloud is an absolute pain for me, which one of my videos will explain why coming up. I'm horribly dyslexic, so it's hard to read, but I've got all of this memorized. So it starts out pretty basic. You know, atmospheric monitoring programs show the level of carbon dioxide in the atmosphere has increased about 8% over the last 25 years, and is now around 340 ppm. Oh, the good old days. This observation is believed to increase. Ooh, I think I read that wrong. This observed increase, there we go, is believed to be the continuation of a trend which began in the middle of the last century with the start of the Industrial Revolution. Fossil fuel combustion and the clearing of virgin forest, deforestation, are believed to be the primary anthropogenic contributions, although the relative contribution of each is uncertain. Remember, this is the 1980s. Now, EXXON at this time, between the 70s and 80s, did a ton of climate research, so they actually have a fairly good idea what's going on, but there's still a lot of uncertainty because, again, it's the 80s. So, yeah, there is a lot of that. The carbon dioxide, I'm not going to read the whole thing through, I'm just going to pick out sections, but this first page is kind of important. Atmosphere, since the effect of global climate. Yeah, the carbon dioxide content in the atmosphere is of concern. Oh yeah, now EXXON's saying it. Because it can affect the global climate. Carbon dioxide and other trace gases contained in the atmosphere, such as water vapor, ozone, methane, that's a big one, carbon monoxide, oxides of nitrogen, couldn't read that for a second, absorb part of the infrared rays re-radiated by the Earth. Again, dyslexic, I have a hard time reading some of these things. This increase in absorbed energy warms the atmosphere, inducing warming at the Earth's surface. It's interesting, actually, because I've memorized a lot of this, because I use it a lot when I'm arguing, and I still have a hard time reading it, even after that. But yeah, this is referred to as the greenhouse effect. Oh boy, so the greenhouse effect and global warming are not a modern trend. Predictions of climatological impact of carbon dioxide induced greenhouse effect draw upon various mathematical models to gauge the temperature increase. The scientific community generally discusses the impact in terms of doubling of the current carbon dioxide content in order to get beyond the noise level of the data. Yeah, this is important because they did a lot of climate modeling, and again, things weren't as precise at this time, so there was a lot of noise, and they knew that there was probably warming because the first inclinations of man-made climate change actually date back to the late 1800s. Like, I'm talking 1880s, 1890s, when scientists first started thinking that, or started noticing that ash from burning coal impacted local climates, usually cooling because we're, reflecting an albedo. But there was also concern amongst scientists that carbon dioxide, if put too much, could, increase warming. Because they weren't stupid. Like, people seem to think that climate change is a new thing. It's like, no, they were back in 1890 talking about too much carbon dioxide can cause warming, because if you understand how carbon dioxide operates, it absorbs and, re-radiates infrared heat, as they stated in this paper, very easily. You can test this in your backyard. So, but still, jumping to conclusions is not good. So there was a lot of noise here, so they had to be very cautious in their wording, as we'll see. Where was I? The scientific community, we estimate doubling could occur around the year 2090 based upon fossil fuel requirements projected in EXXON's long-range energy outlook. So they knew in 1982, they knew that their projections were going to cause problems, and they just kept going. The question of which predictions and which models best simulate a carbon dioxide-induced climate change, oh, there's that word that's apparently not brand new, is still being debated by the scientific community. That is true. This was the 80s. They had to make sure that they weren't jumping the gun. Our best estimates is that the doubling of the current concentration could increase average global temperatures by about 1.3 degrees to 3.1 degrees Celsius. Alright, so although at this point they're still not 100% sure if humans are causing it, they do predict that if it's doubled, there will be massive warming. This increase would not be uniform over the Earth's surface, which is what we're currently seeing, with the polar caps likely seeing temperatures increases on the order of 10 degrees, and the equator little, little, if any, increase. That's actually true. Right now, climate change is most prominent in the poles, and I don't actually know why. I remember reading about it a long time ago, but I forgot, and I'm not going to pretend or make something up. I will honestly admit I don't know why that is. It might be because of just it's cold. I don't actually know. I know ozone depletion also, like atmospheric stuff. Maybe it's the rotation of the Earth, Coriolis effect. I don't know. Something, for some reason, the poles are affected by atmospheric changes more than the equator. And we're seeing that. The ice caps warm much faster than everywhere else. So they were correct in this paper, which is very depressing. Considerable uncertainty also surrounds the possible impact on society of such a warming trend should it occur. Oh boy, would it. At the low end of the prediction temperature range, there could be some impacts on agricultural growth and rainfall patterns, which we're currently seeing, thank you very much, which could be beneficial in some regions and detrimental in others, which we're also seeing, thank you very much. Because there is something to be said there where people are like, oh, if the climate warms, some places become more habitable, and like that is true. Some places will become more temperate. Rainfall patterns will make some places greener, while also making other places less green. So it's kind of a patchwork, and you have to determine pros versus cons. And when you look at it, the cons outweigh the pros. One issue also is if CO2 concentrations get too high, people are like, oh, it greens the planet. Plants love the CO2. This is true. But if concentrations get too high, the leaves actually start to thicken, and the plant's nutritional content drops. Again, I don't know why. I just read this in a few papers because I like botany. I should have paid better attention as to why. I think it's some kind of mechanism in the plant. Point is, it's not good. And where was I? At the high end, some scientists suggest there could be a considerable adverse impact, including the flooding of some coastal land masses as a result of the rise in sea level due to melting in the Antarctic ice sheet. Also, Greenland is a big one that we need to worry about. Such an effect could not take place until centuries after the 3-degree global average temperature. Oh boy. Yeah, we wish, but it's gotten pretty fast. Increases actually occurred, yes. Now, this is important here because they also say there is currently no unambiguous scientific evidence the Earth is warming. That is true. By this time, there was no 100% it is warming, but there's a lot of like projections that show it probably is. And with our better sensing equipment now and doing ice cores, we've determined that, yeah, okay, the Earth actually did start to warm at an unusual rate starting in the late 1800s, early 1900s. So this was actually correct. But remember, they had to say unambiguous because there was evidence. In fact, some of the earliest evidence of an unusual warming started around 1932? 33? The point is, there was discussion in the 1930s about some anomalous warming being detected, in remote sensing on the planet. But again, you couldn't for sure say what it was because there are things that can affect global climate. Like a volcano erupting, a big one, can cause temperatures globally to cool for 2 or 3 years. So you have to be careful with jumping to conclusions. I respect that. Unfortunately, this unambiguous evidence has become no longer unambiguous, and we know what's going on. Like, for example, they say it's likely not to be detected before 1995, which we actually started getting very unambiguous evidence of warming starting in actually the late 80s. So shortly after this came out is when we started realizing, oh yeah, it's happening. So they were wrong about that. But again, it's projections. Temperatures, fluctuations. On the other hand, if climate modeling uncertainties have exaggerated temperature rise, it is possible that a carbon dioxide-induced greenhouse effect may not be detected until 2020 at the earliest. Yeah, that didn't happen. We started detecting unambiguous detections again shortly after this paper came out. Or memo, it's not a paper. Which is unfortunate. Very unfortunate. I'm laughing because this memo annoys me. Which is why I'm going to be sending it to their corporate offices to annoy them, because it's a form of protest that hurts nobody, except I have to pay for 46 pages of paper, but I'm going to double-side it, so it'll be less, because I try to care about the environment as much as I can. I'll use recycled paper, how about that? And double-side it. Anyways, mitigation of the greenhouse effect would require a major reduction in fossil fuel combustion. See, shifting between fossil fuels is not a feasible alternative because of limiting long-term supply availability for certain fuels, although oil does produce about 18% less carbon dioxide per BTU of heat released than coal. That is true. Natural gas is cleaner than coal, but it still sucks. But yeah, this is a big issue here, because they say mitigation would require major reduction in fossil fuel combustion. Now this is EXXON. They're a fossil fuel industry. They don't like that. So this, can I highlight this? I cannot. This sentence, or this section is very relevant as to what happened over the next preceding 40 years up till now. And I'll get to that here in a minute. Limited supply, blah, blah, blah. The energy outlook suggests synthetic fuels will have a negligible impact, at least through the mid-21st century. They were kind of wrong about that. They actually could help. Less than 10% of the total carbon dioxide released from fossil fuel combustion by the year 2050. I read something wrong here. That did not make any sense to me. The energy outlook suggests synthetic fuels will have a negative effect on by the mid-20th century, contributing less. There we go. Released from fossil fuel combustion by the year 2050. Okay. Again, I'm horribly dyslexic. That was a real pain to read. This low level includes things. So this is basically them complaining about how there's no alternatives to oil, which in some areas that's true, in others it is not. One thing I always say is the airline industry, like jet fuel is probably going to be fossil fuel for quite some time. Although we could potentially do synthetic fuels, that might work. Because jet fuel is basically just kerosene, so if you can make synthetic kerosene and make it carbon neutral by just using carbon from the air or whatever, or from plants, then that would work. But barring that, I always say air travel is the one area that's probably going to be the last holdout for fossil fuels, because it's just very difficult to make an electric plane. Not impossible, but for a large one, I don't know how feasible it is. And I don't think I'd trust a hydrogen plane, personally. I wouldn't. it wouldn't be safe. For now, surely maybe in the future, but my opinions, that's just an opinion. That is not a stance, that's just an opinion. Alright, overall, the current outlook suggests potentially serious climate problems are not likely to occur until the late 21st century, or perhaps beyond, at projected energy demand rates. Oh, you sweet summer child. Unfortunately, those demand rates have spiked, and yeah, so we're seeing these potentially serious climate problems now much sooner. Like, we're talking 2040s. Actually, we're talking currently right now, but they're going to get progressively worse unless we do something about it, so that's just fun. It should also allow time to better define the effects of carbon dioxide and other infrared-absorbing gases on the surface climate, making significant changes. This is their trying to be hopeful section, where they're like, all of our modeling shows it's going to be a problem, but maybe it won't be a problem for a while. Yeah, talking about how to fix the economies. Alright. Proprietary information for authorized company use only. Oh well. Right. And now we get into the actual, scientific part of this. So that was all just the intro. And this is the part where it's just saying, yeah, we may have screwed stuff up, but, it might be fine. We don't know. There's a lot of noise in the data. But yeah, so the background, atmospheric monitoring. Oh yeah, NOAA. National Oceanic Atmospheric Administration. This is them talking, basically this is just all the information talking about their climate modeling, where they've noticed that there's been an increase in atmospheric carbon dioxide due to fossil fuel burning. Here we go. There's little doubt that these observations indicate a growth of atmospheric CO2. See figure 1 with that below. It is also believed that the growth of atmospheric CO2 has been occurring since the middle of the past century, i.e. coinciding with the start of the Industrial Revolution. So here we have ExxonMobil admitting that carbon dioxide has been rising because of human activity in this memo from 1982. Because this was only supposed to be internal. They weren't going to release this, and I'll explain why in a minute. Talking about how concentrations have increased. The greenhouse effects, it's just basic terminology. Right, this is one of their projection models showing, it's sideways, showing carbon dioxide concentrations versus time. It goes up and down based on the seasons, because in the wintertime, obviously, there's less plants photosynthesizing, so there's less carbon being captured, so it rises. Then in the summertime, plants bloom, so it drops, rises, drops every year. But because there's more carbon dioxide going into the atmosphere than being pulled out in this cycle, it builds up slowly, and over the course of these years, it just goes up and up and up and up and up. Again, this is an ExxonMobil not publication, but memo chart. This is their research using NOAA information. This isn't the evil anti-oil scientists. This is literally the oil company doing this stuff right here. And then it goes on, highly respectable scientists, such as Woodwell, Bolin, and others, have a net biomass contribution to the atmosphere that ranges from what one, Yeah, this is talking about the flux, basically like the CO2 reservoir and stuff. It should be known, however, that the rate of forest, I'm talking about forest clearing, also causes problems because it re-emits carbon and reduces that carbon sink, which is kind of a buffer. So the impact of fossil fuel must be considered in the context of the carbon sink. So basically, how much carbon dioxide is being released versus how much is being absorbed, and how much carbon sink is being lost, is what they're getting at here. And calculations recently completed at ExxonMobil. So this is just them talking about, it's the carbon sink. What is all this? Impact on weather, climate, and land availability. The most widely accepted calculations carried on thus far on the potential impact of climate of doubling the carbon dioxide content in the atmosphere. These models indicate that an increase in global average temperatures to 3 to 1.5 degrees is most likely, so they're admitting that's probably going to happen. Such changes in temperature are expected to occur within uneven geographic distribution. We talked about that. The ice caps get more than everywhere else. Polar regions, oh man, this is hard to read. These calculations are compared in figure 5. Got that. If the atmospheric CO2 content had been 295 ppm prior to the Industrial Revolution, and an average global temperature increase above climate noise is detected at the present time, this would add credibility to the general circulation models. However, if the CO2 concentrations had been to the Industrial Revolution, so basically they're trying to filter out the noise versus information, but they're skewing pretty hard towards that it's going to happen because of their modeling. But again, they can't jump to conclusions, because these were scientists who did this. This wasn't evil corporate executives. It was evil corporate executives who used this for evil, but it was scientists who made this. Alright, now this is the most important one that people always cite. This is their projected atmospheric carbon dioxide versus global temperature versus year. Now, this was 1982, so we're looking somewhere around there. Anyways, and the important one here is we're in 2023, almost 2024, so we're kind of up here. And so you can look at global average temperature versus BPM. It's somewhere around this 400, 420 region, 1.2. And I'll put up the actual current, like this year's atmospheric carbon dioxide versus global temperature increase. And you can see that this chart is actually pretty close. It did a really good job predicting the rough range of atmospheric carbon dioxide versus average temperature increase. And it's disturbing because they weren't wrong. But again, this is ExxonMobil who did this, and this is an internal memo made just for executives at the company. This was not meant to be seen by me or you, because they don't want you to see this, and there's a reason for that. And then, yeah, carbon saturations. And the rest of this is mostly just more of the same. It's all the information talking about carbon distribution, carbon sinks, the reports, carbon reduction and climate, their assessments. There was one part somewhere here, I need to find it. In addition to the effects of global climate on agriculture, there are some potentially catastrophic events that must be considered. For example, if the Antarctic sheets were to... the sheet, which is in anchorage, which is anchored on land, should melt. This could cause a rise in sea level on the order of 5 meters. Such a rise would cause flooding on much of the U.S. East Coast, including the state of Florida and Washington, D.C. The melting rate of polar ice is being studied by a number of glaciologists. Estimates for the melting at the west Antarctic ice sheet range from hundreds of years to thousands of years. Yeah. Atkins and Epstein observed a 4.5 millimeter raise in mean sea level. That's actually not bad. That's actually pretty accurate. They account for the rise by assuming that the top 70 meters of the ocean has warmed by 0.2 degrees from 1890, yeah, there we go, to 1940, as has the atmosphere, causing a 24 millimeter rise in sea level due to thermal expansion. That's an important one people don't talk about, because sea level rise isn't just water flowing into the ocean from glaciers. It's also, when you heat something up, it expands. When you heat water up, it expands. So the oceans, as they warm, they expand. That's just physics. So, like metal, for example. Metal, concrete, air, fluids, they all expand when they heat. So the ocean, just by merely warming up, because there's so much ocean, a little bit of expansion all over the ocean equates to noticeable volume increase just from temperature rises. This is actually why sidewalks have those like spaces between the slabs, because it allows them to expand and contract without breaking. That's just interesting. Anyways, so yeah, they're accounting for rise. They're noticing rise. It's not a lot here, but it's getting faster. But I'm glad they pointed out the temperature thermal expansion of water, because people ignore that one. Then again, they also ignore carbon dioxide dissolving into the ocean acidifies it, which just destroys ecosystems in the ocean. And people are like, oh, more CO2 is good for the plants, it's good for the planet, it greens the earth. And it's like, yeah, but it's killing the oceans by making them acidic. But again, a lot of these climate change denial talking points, or the ones that say that they don't deny it, but they say it's good, they rely on cherry picking and ignoring entire ecosystems. It's like, oh, it's good for plants in this region. And it's like, yeah, but it's killing crops over here and it's destroying the ocean. But whatever. People will believe what they want to believe. CO2 fertilization could have a broad beneficial effect on agriculture. That is true. These effects need to be studied in detail. I was talking about that. That is true. A small rise in CO2 would be generally beneficial, but if it gets too far, it's reached a tipping point where the damages outweigh the pros, basically, and it's not good. Okay, CO2-induced warming is predicted to be much greater at the polar regions. That is true. We're seeing that currently. It sucks. There could also be positive feedback mechanisms as deposits of peat containing large reservoirs of organic carbon are exposed to oxidation. Similarly, the thawing might also release large quantities of carbon dioxide sequestered as methane, or carbon sequestered as methane, methane hydrates. Yeah, this is important because another thing people seem to ignore is they're always like, oh, it's just carbon dioxide. It makes such a small thing of the atmosphere. And it's like, yes, but it's a tipping point. Because, all right, methane is far stronger a greenhouse gas than carbon dioxide, and water vapor is far stronger a greenhouse gas than carbon dioxide. So the problem is, if we keep dumping tons of carbon dioxide into the atmosphere, it'll warm the atmosphere a little bit. And when the air is warmer, it can hold more water vapor. And when it holds more water vapor, it can hold more heat. And when it holds more heat, it can hold more water vapor. And then that goes on and on and on until we suddenly start seeing permafrost in the Arctic melting, and that releases more methane into the atmosphere. The more methane, the more heat. The more heat, the more moisture. The more moisture, the more heat. The more heat, the more methane released, the more methane. It's a feedback loop. So by screwing up the thermal capacity of the atmosphere using carbon dioxide, we can actually start producing far worse warming through secondary effects. And we can also create cooling as well. And this has actually been shown this year because there's been a rapid spike in ocean temperatures this last year, and they were like, what caused this? And it turns out that there's a very strong case that it was our fault because we were accidentally geoengineering, and then we stopped. Because ocean transport, large ships, they burn a lot of stuff, and they would release a lot of sulfur into the atmosphere, like sulfur dioxide and stuff like that. And then the new restrictions came in place where it's like, all right, these various companies, you have to keep sulfur contents low in your ship fuel. So companies started pulling lots of sulfur out of their fuel. So ships have stopped releasing as much sulfur into the atmosphere. And now temperatures have spiked. And this is because the sulfur dioxide in the atmosphere reflects infrared light, and actually cools the planet slowly in these areas over the ocean. But now, since those clouds of sulfur dioxide are going away, more infrared heat is getting absorbed by the ocean and by the atmosphere, and we're now looking at temperature increases that would have been in place if not for the sulfur in the atmosphere. So this actually does show that sulfur injection into the atmosphere, like sulfur aerosol injection, can be used to control climate change. It would be kind of questionable. That's a tricky topic. But point is, yeah, that was unfortunate. So we're going to see how that pans out in the next couple of years. What was I talking about? Right. CO2 and feedback loops. It sucks. Although all biomass are likely to be affected, the most severe economic effects could be on agriculture. Yeah, basically our food supplies can be screwed over by this. Thanks for letting us know, EXXON, in 1982. Yeah, production of food, fiber, animal, agricultural, tree crops, etc. Information exhibits on the relationship of cultivation and non-cultivated biome to climate fluctuations. Yeah, this whole area is basically talking about how our food supply is rather sensitive to the climate system, and any changes to that can actually cause problems to our food supply. But don't worry, all those climate change deniers out there, I hear they don't actually eat food, so this isn't a problem for them. They don't have to worry about it, because this is only a problem if you eat food. There are situations: soil erosion, sanitization, collapse of irrigation systems. Yeah, that's more just general heat stuff. Trees, special. Research is recommended on the flow of information. Here we go. Research is recommended on the flow of information on risk perception and decision making to and from both laymen and experts, the physiological aspect of understanding and perception, and the factors that influence decision making. That is also a very important one. Basically, they're talking about they need to do more research on how are they going to talk to the general public about these topics. I'll give you a hint. The answer is they don't. But that's very important. There is a need to make sure the lifetime exposure to elevated CO2 poses no risk to the health of humans or animals. Yeah, about that. In terms of societal and institutional responses to an increase in CO2, the AAS DOE workshop, I have no idea what that means, I must have missed that, participants felt that society can adapt to the increase in CO2, and that this problem is not as significant to mankind as nuclear holocaust or world famine. Now, they're probably right about that one, because again, this was 82, and I would argue that nuclear holocaust would be a little bit harder to bounce back from. But world famine, I'm sorry my guys, but this can cause global famine, so... Finally, in analysis, the issues associated with economic and geopolitical consequences, it was felt that society can adapt to a CO2 increase without economic constraints that will be existing at the time. Kind of true. I mean, like, we won't die, but our planet will be really crappy to live on. Some adaptive measures that were tested would not consume more than a few % of gross national product estimate to the middle of the next century. Yeah, that's way off, but it's okay. Yeah, then here's basically a summary of a lot of their major programs and research. Talking about CO2 finding its way into deep ocean. That could cause problems there. Well, it's deep ocean sediment. Surface waters. Oh yeah, this is talking about the oceans. Ocean acidification, because nobody ever talks about that. That's a chart. I can't read that. I can hardly read this as is. I'm not going to be able to read this. What is going on here? Groups in Europe have been used Greenland ice cores to independently estimate the CO2 concentrations in the more distant past. While it is difficult to measure the CO2 concentrations of the dated ice cores, the results suggest that the atmospheric CO2 concentration during the height of the last ice age, about 18,000 years ago, may have been about half its present value. So that's important, because you get a lot of climate scientists who are like, look, CO2 was so much higher at this point before industrialization. And it's like, yeah, that's because over millions of years, you're going to see drastically changes in the Earth's atmosphere. But this is saying that during the height of the last ice age, 18,000 years ago, atmospheric concentration was about half of what it currently is. Well, this is 1982, so it's half of what it was in 1982, showing that there might be a correlation there. But again, can't jump to conclusions. There are currently approximately 40 carbon cycle and climate research projects in about 25 different institutions. Many of these projects are either supported jointly by the DOE, Department of Energy, and other agencies, or exclusively by other agencies. The 1982 federal budget request for CO2 research was $23.9 million. The Department of Energy, as the lead agency, would be allocated $14 million. That's a lot of money. I mean, at the time. It's a lot of money for me. I mean, my bank currently has $1,000 in it, so it's a lot for me. Okay, a number of future energy scenarios have been studied. Yada, yada, yada. Just nuclear power, my guy. Nuclear power. I'm saying, just nuclear power. We could solve a lot of this with nuclear power. We could still use fossil fuels for textiles. You don't have to get rid of it completely. Just stop burning it in cars. And boats. Seriously, the shipping industry can be decarbonized easily, and they need to be. Like, if you have all the ocean-going ships just stop using fossil fuels and used, like, hydrogen or wind or even, like, synthetic biofuels that are, like, carbon neutral, it would go a long way. But no. Actually, some companies like Maersk are trying out wind energy, wind hybrid, which is nice. Trains are pretty efficient. I don't worry about them too much. Anyways, the rationality of choosing these limits is economic. Yeah, it always is. The rate of CO2 increase is too rapid. If it is too rapid, then society may not be able to economically adapt to the resulting climate change. Yeah, so basically, they're saying if CO2 rates increase too fast, we can't economically adapt to it. Which, you know, since this came out, it's been rapidly increasing. So, oh no. The second limit is based on the level where the harm due to CO2 would greatly exceed the societal benefits that produce the CO2. Exactly. So that's saying the harm to the planet and to our basically our economy, food supplies, and just general quality of life would be worse than, you know, having a gasoline car, which we don't need them right now, unfortunately. We still, no. Anyways, I'll stop complaining about cars. I'm just kidding. I won't. The second limit, that's right, the threshold inducing irreversible, yeah, here we go. The second limit can be illustrated as the assumed threshold for inducing great irreversible harm to our planet, such as causing a large ocean level rise due to melting polar ice. In addition to improving the energy sources, there is I think I may have missed it, but I'll have to go find it. But there's a section here that's kind of chilling. The study appears to be based on reasonable assumptions, but where's my topic? Development of non-fossil energy sources based on present state of the art implies nuclear energy. Hell yeah, brother. I love nuclear energy. I'm an environmentalist who likes nuclear energy, and you can't stop me. The study also indicates that other energy use related greenhouse gases, carbon monoxide, methane, and oxides of nitrogen, yeah, NOx sucks, may significantly contribute to global warming. Also hydrogen. Okay, this is a bit of a tangent, but we have to be careful with hydrogen because even if it's cleanly produced, it can have a knock-on effect of being problematic to the climate, at least in the short term, because the hydrogen released into the atmosphere will destroy, I think, what is it? It destroys like radicals in the atmosphere that destroy methane. So by dumping lots of hydrogen in the atmosphere, although hydrogen itself is clean and non-problematic, it can affect the atmospheric composition by allowing more methane to remain in the atmosphere, thus causing more warming. So that's a thing we need to worry about when using hydrogen, which I do a lot of research on hydrogen, so I have to keep that in mind. Boy, is it annoying. That's why I like keeping it sequestered in ammonia, because it's just easier to handle. Anyways, back to the paper. Those are projections. The energy use related greenhouse effects, carbon monoxide. I don't know much about carbon monoxide as a greenhouse gas. I should probably look into that. I just never see it come up, but I assume it's bad. Ammonia from fertilizer. Yeah, you have to be careful with that. Again, I like ammonia as a way to store hydrogen, but be careful with it. However, one thing is it's easier to contain than hydrogen, so you can prevent spills. And if it does spill, it's not immediately toxic to the environment, but it's not good for the atmosphere, so you don't want to just dump it around. Yeah, N2O, nitrogen dioxide, is more reactive than carbon dioxide. No, wait, that's dinitrogen oxide? No, nitrogen dioxide, yeah. No. That's N2O, that's dinitrogen oxide. Oh, it's just NOx. Okay, never mind. I'm being dumb. And is expected to have a relatively shorter atmosphere rather than... Yeah. So yeah, this is basically, they're just talking about forecasts of various compounds in the atmosphere, problems that can occur in the future. These are all numbers, because they have the receipts, because it's important. What industries produce a lot more stuff. This video is going on for a very long time. I need to actually speed up here. It is anticipated by most scientists that a general consensus regarding the likelihood and implications of CO2-induced climate change effects will not be reached until such time as a significant temperature increase has been detected, which it has been, and that consensus has already been made. ExxonMobil predicted it would happen, and they knew it would happen. So that's fun. A number of climatologists claim that they are currently measuring a temperature signal above climate noise. Yep, again, I mentioned that from 1932 onward. I'm talking too fast. 1 second. So this is them basically talking about how long they can hide it. I mean, they're not saying that directly, but that's literally what it is. Yeah, here, this is them talking about how it was detectable in 1979. Of course it was. The doubling of CO2 will cause a 3 degrees temperature rise when it should have seen a temperature increase above climate noise. Yeah, so basically just talking about climate consensus and projections. Yeah, there's some uncertainty. Where is it? Oh, are these sources? Oh, this is all their sources and information and stuff. So this is basically the gist of this. It was released to talk to all of their higher ups in ExxonMobil about the problems facing us because of climate change and what to do about it. Where is it? There's a very important section here. Where was it? There's an important section here that is disturbing, and I can't find it. Trends, maybe it was down here. I will find it in a second. If not, I can just tell you what it was. But I want to find it. Where'd it go? I know it was. I'm pretty sure it was up in the forward. Effect. F's increased. Melting. Take place. Yeah, come on. I know it's here a second ago. Oh, here we go. Right here. However, there is a concern among some scientist groups that once the effects are measurable, they might not be reversible, and little could be done to correct the situation in the short term. Yeah. Therefore, a number of environmental groups are calling for action now to prevent an undesirable future situation from developing. That's important because of what happened next. So, alright, this paper was 1982. ExxonMobil knew what was happening, they knew what was up. What did they do? They buried this. They covered this up. They did not release it. They stopped doing climate modeling altogether completely, and then they started funding climate change denial. What they did was they copied the tobacco industry, and they found ways to try to manipulate people into not believing it because they wanted to intentionally slow acceptance of climate change as much as possible, because they knew that this information was problematic, and they knew that if it got out, people would be pushing for more climate action and fossil fuel reductions, and that would hurt their bottom line. So they spent the last 40 years spending millions of dollars setting up, like creating and funding think tanks and organizations specifically tasked with making disinformation and spreading lies. They were the ones who came up with the global cooling. They're the ones who came up with solar, like the sun's changing things are what's causing climate change. They're the ones who came up with all of these really stupid explanations that climate change denialists use, because they wanted people to believe in anything else except this. All of their information, they wanted people to not believe it. They wanted people to reject their findings because they didn't want to lose money in the long term. They wanted their profits to be secure. And it's very depressing because once you realize that modern climate change denial is literally a scam created by a fossil fuel industry, specifically ExxonMobil and BP and Shell, just to save money. And people believe it, and they're like, oh yeah, those scientists are brainwashing you. It's like, no, ExxonMobil is brainwashing you. They've known about this for 40 years, and they still paid millions of dollars to save billions of dollars in profits. And it's very upsetting and very depressing. In fact, the oil industry is also the ones who came up with the carbon footprint idea. The idea that it's your fault that climate change is happening, and that we all have to reduce our carbon footprint. That was their fault. Now, it's true that we can do things to reduce our energy usage, and that's good, but we're very minor compared to what they've done. So, whenever you have policies that blame you for climate change, that's Exxon. Whenever you have people who tell you the sun changing luminosity is causing climate change, that's Exxon. Whenever you see anybody talking about natural cycles in the short term, that's Exxon. They literally made all this crap up. They hired think tanks to make this crap up, and they hired lawyers who helped the tobacco industry to spread false information to make crap up. It's also similar to like when they discovered that lead from lead gasoline was poisoning people in the air. The companies responsible, like the petrochemical companies, tried to intimidate scientists and hired people to push lies about how lead isn't poisonous in the air because they didn't want to lose money. So it's like companies will do this. They will literally lie about lead poisoning. They will lie about putting poison in wine. They will lie about climate change to save money. So when you have climate denialists telling you that it's all some conspiracy, they will do this huge, long, convoluted conspiracy that does not align with anybody else because in their head it's this big, huge thing. But they will never accept that Exxon will lie to save money. And this is why I care so much about the environment. This is why I study this. This is why I'm currently working on renewable energy projects and have been losing sleep over these projects, because I care so much about this, because we are 40 years behind where we should be, because these people are evil. They are legitimately evil. I hate to turn this kind of fun, campy video into reading this thing into a lecture, but they're evil. Like, they're actually evil. This was never supposed to be circulated in public. They were never supposed to get this information out to public. They were supposed to keep convincing us that they didn't know, but they knew. So yeah, there you go. I will be linking this down below. You can read it yourself if you want. It's a depressing read. Print it out, send it to them. No one's going to watch this video, but if you did, thank you for watching. I hope you enjoyed. I'll be back with real videos after this. I just wanted to talk about this because it's annoying me, and now I feel better. So, thank you all for watching. I hope you enjoyed, and ExxonMobil.